guys, my name is Iman, and in this tutorial I'm going to explain how to work with one of my MATLAB GUIs called TSAF. It stands for Time Series Analysis and Forecast. First of all, if you are interested to understand the concept behind this GUI, please watch this tutorial. So just click on this question mark and you can watch some tutorial on the concept. Now let's go back to the GUI. This GUI consists of three main sections. This section is to analyze data. So you can import data from an Excel file, you can find seasonality, and then you can remove and trend. You can remove trend and seasonality. So basically, this section is to analyze data. In this section, you can see correlation and autocorrelation with different lags. And finally, this section is to build the model and forecast the future. Let me show you a simple example. Test. So in this graph, you can see the signal in time domain. And in this graph, you can see the signal in the frequency domain. And in this graph, you can see autocorrelation, or you can choose partial autocorrelation with different lags. For example, 40. Let's go back to autocorrelation. Now let's analyze this time series and try to assign it to a model. First of all, as you can see, there is a trend here. So the trend here is kind of linear. So let's assign differentiation to 1. This differentiation is our D element. So as you can see, trend is almost gone. And if you look at the frequency representation of signal, you can see some obvious spikes. These spikes are corresponding to different harmonics. So for example, let's find three largest harmonics. So this spike is corresponding to this period, 12. This spike is corresponding to a period equal to 6, and this one is corresponding to period equal to 8. If you want to find a fundamental period for this function, we need to find the least common multiple between these three, so approximate it. So seasonality is approximately every 24 samples. So this is our seasonality, which is the least common multiple between these three numbers. Now in order to remove seasonality, just type 24. So this D season is in fact our S element. So this isn't it. After we remove trend and seasonality, as you can see, autocorrelation tails off gradually, but partial autocorrelation cuts off exactly after 2 lags. So this tells me the model is an autoregressive model with the order of 2. So we are done with the time analysis. We know the model because we know we have 2 lags for the AR part, and we know differentiation is 1, or D element is 1, and we know seasonality is 24. So let's build the model. At this point, we build the model, and now we can predict the future. How many samples do we want to predict? For example, 24. How many times do we want to repeat it? For example, 50. Because the input is random, so you need to repeat it several times to get different path. Now, let's forecast the future. The blue one is historical data. What you can see here is our forecast for the future, and you can save this forecast. As you can see, data is saved in a file named forecast XLS, so it's saved in an Excel file, and also the model is saved, so you can use it later. So you can save forecast and model. I think that's it for this tutorial. I'm gonna show you another example in next tutorial. Thanks for your time and watching this video.